Anti-dual cosine minus sine, right? I'm sorry, it's sine. Pi over 2 minus pi over 2, right? So this is equal to 1/2 sine pi over 2 minus 1/2 sine negative pi over 2. Sine pi over 2 is 1, so this is 1/2 minus sine minus 1/2 is minus 1, so this is minus 1 over 2. So this is 1/2 plus 1/2, so the answer is 1. The area of this is 1. Now I think normally they probably give you, I hope they give you a picture in the back of the book. It must be better than my drawing. Okay? So let me see if they actually give you the picture. 20, number. I'm doing 21. Okay, so their picture is much better than mine, but I think the picture, of course, in the back of the book, I'm sure it's generated by computer, so mine certainly cannot compete with it. But if you look at the sketch, it looks alike. Okay. Sketch, the sketch to go out. It looks alike. But this is generated by computer, so it's much better than mine. Okay, mine is generated by hands. Anyway, the area of this is 1. Yeah, 1. You see, the answer is 1 here. This is very, very interesting. Also, those things. So 10 points. Let me see if I can draw some more. Alright, so how about let's do it 25. 25. What's 25? Okay. 25 is the region in 25, okay? The region inside, this is a name. Demarco or something. Demarco is a name. Name is for this graph. R equal to 2 plus cosine theta. This graph, they have a special name. So why don't we draw this picture, see what it looks like. Okay. Now for this one, I remember for number 27, we have drawn a picture of this. We draw R equal to cosine 2 theta, right? At that time, cosine 2 theta, we have 4 leaves. Remember, we have these 4 leaves. So 3 theta, you have 6 leaves. It's 2 times of this number. 6 leaves. This has 6 leaves. This is 6 leaves rows. But anyway, let's do 25. The region inside whatever this name is, but this is for this curve. I equal to 2 plus cosine theta. So 25 R equal to 2 plus cosine theta. And then the first thing we need to do is draw a picture to get a feeling of what we are dealing with. Okay, what we are dealing with. So again, you do this theta, right? So your theta is, say, start with 0, cosine 0, 0, right? And 1, so it's 3. Okay, and then you increase the number pi over, increase with, say, pi over 4. That will be square root 2 over 2, right? So square root of 2 over 2 is about 0.7. Okay, so this is about 2.7. I just want to give you a number, roughly speaking, about this number. And then when it's pi over, say, pi over 6, cosine pi over 6 is 1/2. So it's about 2.5. Okay, and then when theta is, no, sorry, I meant 3.
3, yeah.
Okay, when it's 2 here, pi over 2, cosine pi over 2 is 0, so this is 2. Okay. And then pi over, say, the next over, say, 3 pi over 4. Cosine 3 pi over 4 is negative square root 2 over 2, which is 1, negative 0.7. So this is 1.3 over this number, roughly speaking. Okay, and then how about pi over 2 pi? Pi. Yeah, so pi. So cosine pi is negative 1, so it's 1. So it's getting smaller. Okay, so let me see. So let me show. So see if we can draw a picture of this. Okay? So when theta is 0, angle. Remember, it's always like this. This is theta. This is r. There's a 4. Okay. When theta is 0, r is 3. So say this is 3. This one is 3. Okay. Pi over 4. When pi over 4, 2.7. So maybe here. Okay. Pi over 3, 2.5, getting smaller actually. Okay, and then pi over 2 is 2, getting smaller. Actually, 3, 2.7 is here. This one is 3, right? 2.7. 2.5 and then 2 over here, so it's like this. Like this one. Yeah, this is 3 and this is about 2. And then 1.3 getting smaller. And then becomes 1. Something like this. 1. Alright, so the other side should look like this too. Okay, so it looks like this. And symmetric should look like this. Looks like this. This should be the picture. Okay, so let me just show you that. I hope they have pictures. 25, I hope. I mean, their picture is better than, so this is what I'm looking for. That's the area I'm looking for. Yeah, 25. Yeah, this is, again, computer generated, okay? This looks like this. And this one, and this is 3. And this is 1. You see? 3, negative 1. This is the same as what I draw. But you think it's so different. And the computer more accurate like this. Okay? So this is same thing, right? Alright, then I need to find the area. Okay? So area is what? So this is A, B. I'm going to find this area. It's what? 1/2, right? Integral. So you go from 0 to 2 pi. Okay? And then this f of theta squared d theta. That's the area. So it's 1/2 0 to 2 pi. F is this guy. 2 plus cosine theta squared. So this is 1/2 0 to 2 pi squared, right? 4 plus 2 times 2 times it, right? Plus the square of this. This is fine. The integral of 4 is okay. Integral of this is fine. The problem is this guy, cosine squared. Okay. So how do we integrate this? That's the problem. These two are easy. This is not easy. So, but anyway, so let me integrate the first two and then have this one. So 1/2. So the first one, the second one, those I have no problem. It's the third one that I have to do some math. Alright, so the first one, 4, right? The antiderivative of 4 is 4 theta, 0, 2 pi 0. Okay. Plus antiderivative of cosine is sine, right? So it's 4 sine theta, 0, 2 pi. Now, how about this cosine squared? For cosine squared, I have to use an identity. It's cosine squared is equal to 1/2 of 1 plus cosine of 2 theta is equal to this. I have to use this identity. Okay? So this is 0 to 2 pi 1/2 plus 1 cosine 2 theta over 2. Alright, so this is 1/2 for 2 pi, right? 4 times 2 pi, a pi minus 0, so it's a pi. Sine 2 pi 0 minus sine 0 is 0. Okay. This one 1/2 okay, 1/2 and what? And then theta, right? So it's theta 0 to pi. Okay, and then plus, right? Antiderivative of cosine is sine. Okay, so this is now I have a 2 here. Antiderivative of cosine 2 theta is 1/2 sine of 2 theta. One half a pi, and this 0 down. If I plot 2 pi here, right? 2 pi times 1/2 pi minus 0, and then sine of 4 pi is 0. Sine 0 is 0, so this is really down. Or 0. So this is 9 pi over 2. Yeah, 9 pi over 2. This is the area of this piece. Alright, so I guess that's all for today.